Hi everyone, and this is example 1 on how to calculate and predict correlation R given certain data, and we're also going to do the line of best fit. So here's our data given. We have a certain math class, and the relationship is homework done percentage-wise versus their grade. And we have to represent the data on a graph. So the best way to do this is on Excel spreadsheet. So you use the Excel and you'll get something like this. Now I just did a scan on this, so it doesn't look so great. But when you're looking at it on the Excel spreadsheet, we can look at this and kind of draw a line through that, and we have to determine if there's a correlation. So we're going to look at it and say, is there a correlation? And we're just going to do a prediction. So it seems like a strong positive correlation. So this is yes, and then this goes here. What kind? Strong positive correlation. So we know on strong positive correlation, that means our correlation coefficient is in this interval. So let's try to predict it. And if I were to predict it, I would just say, let's say 0.85. And we are just guessing here. Now we want to actually calculate it. And to first calculate it, we have to find the mean of x. This is going to be our x and our mean value of y. So basically, you're just adding up the numbers. 58 plus 90 plus 75 plus 50 plus 40 plus 95 plus 100. I'll put them down here. Plus 85 plus 75 plus 82. Add that up and divide by your total, which is 10. And when you do that, you're going to get 75. And do the same thing for y. Add all those numbers up, and you'll get 75.5. Now, we're going to complete the table to get our R. And what we're going to do is list our x values and our y values vertically. Then take our number, and so for this one, I would take 58 minus my mean value of x and square it. And I put this number in here. So you have to do that for all of these. And I already did that, so you can practice doing that, and you should get 289, 225, 0. Of course, 75 minus 75 is 0. Then we'll get 625, 1,225, 400, 625, 100, 0, 49, and then add all those up to get your total. So we're going to need that for a formula. So this is 3,538. Now you do the same thing for your y values. So for this first one, this would be 70 minus 75.5 squared, and that's going to give you 30.25. And do that for all of these. 20.25. This one's the same. This one's 110.25. This one's 420.25. 6.25. 110.25. 182.25. 42.25. and 30.25. Then you add all these up and you get 972.5. And finally, we want to calculate this so we can also do our correlation coefficient. And that just means we're multiplying these two, whoops, let's see, I dropped my pen. Multiply these two numbers. So when you multiply those two, you're going to get 4,060, 7,200, 6,000, 3,250, 2,200, 7,410, 8,600, 7,565, 6,150, and 5,740. Then add all those up and we get 58,175. Okay, finally, we're going to use the table to find our sum of x, sum of y, and sum of xy using the formulas taken from the IB booklet. So basically, for our first one, and using our table, for this one we're going to get s of x equals the square root of 3,538 divided by your total number, which is 10. And this is approximately 18.8. So for our y, we do the same thing. We're going to get 972.5 divided by 10, and that's approximately 9.86. And then your xy, that's going to be, for your formula, we're using this formula, that's going to be this number, that's why we calculated that, 58,175 minus 750, remember our totals we did, times 755 divided by 10. And that's approximately 155 or 155. So there's our three numbers that we have. Now we find R using this formula. So now all we do is plug it in, our three numbers. We have, let's use 155 divided by 18.8 times 9.86. Now that equals approximately 0.836. So how was our prediction? Well, our prediction was 0.85. So it's indeed a strong positive correlation. So you had a good prediction. Now for the line of best fit, what we want to do is the line of best fit is the straight line that most approximates to the scatter plot. So what we want to do is write our expression. We're just going to rewrite this expression for that. So the way you do that is using this. This is the equation of the line. So the way we're going to rewrite it in this form is we're going to write it as y equals s sub xy divided by s sub x squared, and then plug in your x, because that's your slope, so x plus, we're going to do our, we're bringing this guy over to this side, so that's going to be the mean of y minus s sub xy divided by s sub x squared times the mean of x. So that's just rewriting the formula. All right? And the slope of the line, therefore, is just this. So our slope, m, is going to equal s sub xy divided by s sub x squared. Now, so given the data, we can plug everything. We know our r is going to be 0.836. We did that. And then plugging everything else in, we plug in our slope. You're going to get the slope equals 0.438. Then we have x plus b. And plus b is this amount. So you plug those values in and you'll get 42.6. So you use this formula to multiply everything throughout. You take your mean of y minus all the information that you already have, and you will get your line of best fit. This is a y. So y equals this. And that's how you do it by hand. If we use our graphing display calculator, we're going to get the same thing. We're going to get r equals approximately 0.836, and we're going to get y equals 0.438x plus 42.6. Now, how you do that is, let's look at the graphing calculator. Okay, so the first thing you want to do is go to your catalog. That means you click second 0. When you do that, you'll get your catalog. You scroll down to diagnostics on. So scroll down to that and click enter, and you'll see that window. You click enter again and you'll see done. So you're clicking enter twice. Now we're going to do the line of best fit by using our stat button here. So go to there and click on edit. So number 1, input your data. So I inputted the data. This is the top portion because we had 10 lines total, or 10 columns. And then this is the second half of it. All right. Then you go back to stat, go to calculate, and then you go to number 4. Click enter. So you click enter and you'll see this window. Then go to calculate, hit enter, and then you will get your regression line, linear regression line. So we're just going to write it out. Y equals 0.438x plus your B, which is 42.6 0.4, 0.6, and there's your R. The R is given here because we turned the diagnostic on. So that's going to be 0.83, we'll call it 6. And that's it. Thank you. Have a nice day. Bye-bye.